Hey, my name's Gab. In this video, we'll share what we learned in our robotics class this semester, based on our experiences working with different components.
Hi, I'm Ashley, and we'll be talking about servo motors, ultrasonic sensors, and LCD screens.
And I'm Aliyah. This video is a reflection on what we learned, the challenges we faced, and what you can expect from this course.
First, we have a servo motor. It is designed to move to specific angles, not just spin randomly. At first, we didn't really understand why that mattered, but we later realized it's what allows robots to move in a controlled way. Unlike a regular DC motor that keeps spinning continuously, a servo motor knows where to stop and where to move next. Learning how to control angles changed how we view movement in robotics. Before this class, we thought robot movement was very complicated and didn't really understand what made it happen. We eventually learned that servo motors play a big role in this. We also faced challenges, especially when the servo didn't move to the angle we expected. Sometimes we only wanted it to move to 180 degrees, but it would rotate incorrectly. These issues taught us that small mistakes in writing our code can cause big changes, and that robotics really require patience and careful testing.
Next, we work with the I2C LCD. It showed messages like hello, the light value from the photoresistor, or even scrolling text. It also displayed the distances from our sensors, so we could actually see what the robot was detecting. Feedback is super important in robotics because it tells you if your robot is responding correctly. Without it, you'd be just guessing whether the problem is in the code, the wiring, or the component itself. Seeing the values on the screen made it way easier to understand what was going on. I2C also made wiring much simpler. An LCD requires only 4 pins, whereas a standard LCD needs many more. It made our setup cleaner and less confusing, which is great when you're just starting. During debugging and demos, the LCD really helped. We could see what was working, catch errors faster, and explain the project better because the screen showed the messages and data rather than just pointing to the robot.
The ultrasonic sensor measures distance by sending out sound waves and waiting for them to bounce back. The time it takes for the sound to return tells the system how far an object is, even though we can hear the sound. It's constantly detecting what's around it. In practice, we felt that the sensor was accurate, especially when we used our hand as the object for detection. It was actually cool to see the values change in real time as we moved our hand closer or farther away. However, we noticed that its readings depended a lot on the angle, proper placement, and where the sensor was facing. When it was facing directly in front of us, the readings became unstable, but placing it correctly made it more reliable. Because of this, the sensor allowed the robot to interact with its environment by detecting objects, triggering actions, and supporting basic automation.
Moving on, we created tasks that demonstrated how system thinking works. In the mini gate system, pressing the button triggered the servo to move like a barrier gate, while the LCD simultaneously displayed messages such as gate open and gate closed, along with the servo's angle. Everything worked at the same time, allowing the system to function automatically. In the dynamic message display task, turning the potentiometer acted as a sensor and changed the messages shown on the LCD, giving instant feedback that the system was responding correctly. Seeing the components interact in real time made us understand how automation works. These system interactions changed our understanding of automation because we realized that tasks could happen automatically without human attention. For example, a gate can open and show its status on the screen by itself. Working on these tasks help us see how automation can make everyday things easier and more efficient.
The most challenging part of the activities was managing our time. Most of the tasks require a lot of care and patience, so we had to carefully follow the steps and check the instructions to make sure we were doing everything correctly. Since robotics only happens once a week, missing a session or falling behind on other activities can be stressful and make us feel left out. When problems happened, we troubleshoot by checking the wiring code step by step. Sometimes, the issue was just a loose wire and incorrect connection. If we couldn't find the problem, we asked our robotics advisor for help. Mistakes like unplugging the computer before saving our code taught us patience and teamwork. Through these challenges, we developed skills such as time management, discipline, creativity, and problem solving.
Looking back, the most valuable thing we learned in this class was just enjoying robotics while staying curious. At first, it could be stressful, especially since we didn't know how to use Arduino, but we managed to complete activities and tasks because we carefully followed the guides and stayed motivated to see what would happen with the components. This experience can help us in future subjects and projects, especially when creating systems that use sensors, actuators, and displays. I would definitely consider learning more about robotics, especially if it's connected to engineering, because having this foundation will make future learning easier.
One key takeaway from this class is that learning robotics is better when you're eager and motivated instead of forcing yourself. Immerse yourself in the activities, make mistakes, and enjoy the process. To future students watching this, stay curious and have fun while learning. Thank you!